Have you ever pondered on why your computer needs a graphics processing unit, or GPU, to function effectively? Welcome to the fascinating world of computer hardware, where we're about to embark on a journey of understanding the vital role of the GPU in a computer system. The graphics processing unit, more commonly known as the GPU, is an essential component of your computer. It's like the artist of the computer world, rendering images, animations, and videos for your computer screen. Picture this. You're engrossed in an action-packed video game or working on a high-resolution image on your computer. Every single frame, every minuscule detail, every dynamic light shadow you see is a masterpiece crafted by the GPU. It takes the data from the CPU and transforms it into a picture you can understand. The GPU is like the director of a movie, taking the raw script and turning it into a visual spectacle. It interprets data from the CPU and converts it into comprehensible images. It's a process that happens billions of times per second, and yet, we rarely give it a second thought. But the GPU isn't just about gaming. It's also a workhorse in professional workstations, where it's used to render complex 3D models, simulations, and high-definition videos. In these environments, the GPU is often the difference between a project taking days or hours to complete. In the world of artificial intelligence and machine learning, the GPU plays a pivotal role too. It's used to perform complex calculations swiftly, helping computers learn and make decisions faster than ever before. So why does your computer need a GPU? Because without it, your computer would be like a painter without a brush, a movie without a director. It wouldn't be able to generate the images you see on your screen, it wouldn't be able to play your favorite games, or help you design a 3D model. In essence, without a GPU, your computer would struggle to display even the most basic visual data. So what makes up a GPU? What's the structure that allows it to perform its tasks? Well, let's dive right in. The structure of a graphics processing unit, or GPU, is complex, but we can break it down into three main components: the core, the memory, and the buses. The core of the GPU is its heart. It's where all the processing happens. This core is made up of thousands of smaller processing units called shaders. Shaders are versatile little workers that can handle a variety of tasks. They can do this because they are programmable, meaning they can adapt their function depending on the needs of the GPU at any given moment. This adaptability is what gives GPUs their power and versatility. Now, these shaders need information to work with, and that's where the memory comes in. The GPU has its own dedicated memory, separate from the rest of your computer. This memory is used to store the data that the shaders will process. It can hold everything from textures and 3D models to lighting information and screen resolution settings. However, this memory isn't just a storage locker, it's also incredibly fast, allowing the GPU to quickly access and process the data it needs. This speed is crucial because the shaders are processing billions of calculations per second, and any delay in accessing data could slow down the entire operation. Lastly, we have the buses. These are the highways that data travels on to get from one part of the GPU to another. There are different types of buses within the GPU, each with its own specific function. For example, some buses connect the GPU to its memory, while others connect it to the rest of the computer. These buses ensure that data can quickly and efficiently get to where it needs to go. So there you have it, the core, the memory, and the buses. These three components work together in harmony, processing and displaying graphics data at lightning speed. Each component has its own vital role to play, and without any one of them, the GPU wouldn't be able to function. As you can see, each part of the GPU plays an integral role in processing and displaying graphics. Now that we understand the structure of a GPU, how does it work? Let's dive right in. To begin, it's important to know that the GPU and CPU collaborate closely to create the magic you see on your screen. The CPU, or central processing unit, takes care of all the general computing tasks, including running the operating system and most software applications. However, when it comes to graphics-intensive tasks, the CPU hands over the reins to the GPU. Here's how it happens. The CPU sends data to the GPU, including textures, lighting information, and geometric shapes. These are the building blocks of your 3D gaming world or high-definition video. The GPU's job is to take these raw materials and transform them into a coherent image. Now, you might be wondering, how does the GPU process all this data? The answer lies in a concept called parallel processing. Imagine trying to solve 1,000 math problems. If you did it alone, it would take a long time. But if you recruited 1,000 friends, each solving one problem, the task would be completed much faster. That's the beauty of parallel processing. The GPU contains thousands of smaller cores designed to handle multiple tasks simultaneously, making it a powerhouse for rendering graphics. Once the data is processed, it's sent to the rasterizer, a component of the GPU that converts the data into pixels. This process is called rasterization. It's like creating a mosaic, where each tiny stone represents a pixel. The rasterizer carefully places each pixel in the right spot on the grid to form the final image. That's not all, though. The GPU also handles the lighting and shading of the scene. This is where things like ambient light, shadows, and reflections come into play, adding depth and realism to the image. It's a complex process involving a lot of math and physics, but the GPU handles it with ease. Finally, the GPU sends the finished image to the display, where it appears as the high-definition video or game graphics you're familiar with. All this happens incredibly fast, often in the blink of an eye. In fact, for a smooth gaming experience, a GPU must be able to complete this entire process up to 60 times per second. Despite its complexity, the GPU's process can be broken down into these understandable steps. It's a true testament to the power and efficiency of modern technology, transforming raw data into stunning visuals in mere fractions of a second. Whether it's rendering your favorite video game or streaming a high-definition movie, the GPU is hard at work behind the scenes, making it all possible. We've learned about the structure and working of a GPU, but why is it so crucial for our computers? Well, the answer lies in how this piece of technology significantly enhances the performance of our systems, especially in tasks that involve heavy graphics. Let's consider gaming, a popular pastime for many. Modern games are designed with high-resolution graphics, complex textures, and real-time lighting effects. These elements place a heavy demand on the computer's resources. A GPU with its numerous cores is perfectly suited to handle these parallel operations, thus ensuring smooth gameplay. But it's not just gamers who benefit. Video editors, animators, and graphic designers also rely on the GPU's power. Whether it's rendering high-definition videos, creating complex 3D models, or applying filters and effects to images, these tasks are all accelerated by the GPU. The GPU takes on the heavy lifting, freeing the CPU to focus on other tasks and ensuring a more efficient workflow. But the GPU's role extends beyond graphics-based tasks. It's finding increasing use in non-graphics computations, especially in the fields of research and artificial intelligence. Researchers use GPUs for complex simulations, such as predicting weather patterns or modeling the spread of diseases. In artificial intelligence, GPUs are used for training neural networks, a task that involves heavy computations. The parallel processing capabilities of a GPU make it ideally suited for these tasks. It's clear that the GPU is not just an auxiliary component, it has become a critical part of our computers. Its ability to handle multiple tasks simultaneously, coupled with its superior speed, has made it indispensable in today's world. Whether you're a gamer, a creative professional, or a researcher, the GPU is likely playing a significant role in your work. In conclusion, a GPU is an indispensable component that significantly enhances the capabilities of a computer. It's not just about making your games look better or your videos render faster. It's about harnessing the power of parallel processing to tackle complex tasks, push the boundaries of what's possible, and open up new avenues of exploration and creativity. Let's quickly recap the key points about how a graphics processing unit works. We've learned that a GPU or graphics processing unit plays a critical role in rendering images, animations, and videos on your computer screen. It's structured differently from a CPU, with hundreds, sometimes thousands of cores designed for simultaneous processing, making it ideal for graphics-related tasks. We've delved into its working process, understanding how it takes data, converts it into a binary format, and processes it through its cores to produce the images we see on our screens. Finally, we've emphasized the importance of a GPU, not just for gamers or graphic designers, but for anyone who uses a computer. It's a crucial component that impacts the performance of many applications, from video editing software to web browsers. Understanding how a GPU works not only satisfies our curiosity, but also helps us appreciate the power and complexity of the technology we use every day.